Ever wondered what you truly look like on the inside? We often think of our external appearance, but what about the intricate world hidden beneath our skin? Beyond skin and bones lies a complex network of organs, tissues, and fluids all working in harmony. But how can we visualize this inner landscape without invasive procedures? Today we're diving into the science behind one of medicine's greatest inventions, a technology that allows us to peer into the human body with remarkable clarity. It's the MRI, or magnetic resonance imaging. MRI lets us see inside the human body in stunning detail, creating images of unparalleled clarity, all without a single cut or incision. It's a non-invasive window into our inner selves. Here's the secret, the fundamental principle that makes MRI possible. Your body is mostly water, a remarkable fact that underpins much of our physiology. And water, as we know, is full of hydrogen atoms, the simplest and most abundant element in the universe. Each hydrogen atom's proton, the positively charged particle at its core, acts like a tiny magnet, constantly spinning and generating a magnetic field. Imagine trillions of these microscopic magnets spinning inside you right now, each contributing to a subtle yet powerful phenomenon. MRI harnesses these microscopic magnets, these spinning protons, to create detailed maps of your inner world, revealing the structure and function of your organs and tissues with incredible precision. But how do we turn these spinning protons, these tiny magnets, into a clear and informative picture? It's all about physics, the fundamental laws that govern the universe. Specifically, it's about the interplay of magnetism and radio waves working together in a carefully orchestrated dance. The MRI machine itself is a marvel of engineering, giant, powerful, and meticulously designed to reveal the invisible structures within us. Today, we'll explore how it works, step by step, unraveling the mysteries of this incredible technology. We'll also delve into why it's so noisy, those characteristic sounds that accompany an MRI scan, and most importantly, we'll understand how it helps doctors save lives, providing crucial information for diagnosis and treatment. So, put on your science helmet, prepare to be amazed. We're about to unlock the secrets of MRI, a true testament to human ingenuity and scientific discovery. Let's get started on this fascinating journey. Let's zoom in, way in, to the atomic level. We're searching for hydrogen atoms, the most common in your body. At their center is a proton, spinning like a tiny top, creating a magnetic field. Normally, these protons point in random directions, canceling each other out. Imagine dumping a box of compasses on the floor, needles everywhere. This randomness is our starting point. To see inside, we need to bring order to this chaos. How? With a powerful magnet that can align all those protons from head to toe. Inside you are more spinning protons than stars in the galaxy, each one a tiny dancer. These humble hydrogen protons are the stars of MRI. Without them, seeing inside the body would be impossible. Science at its coolest. Time for the big magnet. The heart of every MRI is a super strong magnet, up to 3 Tesla, thousands of times stronger than a fridge magnet. When you enter the MRI, your protons snap to attention, aligning with the magnetic field. It's like turning a crowd into a disciplined army. Order from chaos. This alignment creates a tiny, measurable magnetic signal from your body. The magnet stays on 24/7, powered by superconducting coils cooled with liquid helium to near absolute zero. That's why metal objects are banned, they can become dangerous projectiles. Now, with protons aligned, we're ready for the next step. This invisible order is the foundation of MRI imaging. You don't feel a thing, but your body is now primed for a scientific symphony. Superconductivity and magnetism, science in action. Let's see what happens next. With protons now meticulously aligned by the powerful magnetic field, it's time for resonance, the R in MRI. This is where the magic truly begins as we prepare to interact with these tiny particles in a very specific way. The MRI cleverly sends a pulse of radio waves, carefully calibrated and aimed at just the right frequency to interact with the protons. Think of it as sending a coded message specifically designed for them. This specific frequency is known as the Larmor frequency. It's the resonant frequency at which the protons will respond most effectively. The radio waves are used to push the protons, disrupting their alignment. This precisely timed energy knocks them out of their previously stable alignment, like soldiers suddenly leaning at ease when given a command. They're no longer perfectly aligned with the magnetic field. The protons absorb the energy from the radio waves and as a result, enter a higher energy state. They're now energized and ready to release that energy later. This entire process is resonance. It's the clever technique of using radio waves to precisely and non-invasively manipulate atoms inside your body, setting the stage for creating detailed images. The process repeats methodically. An RF pulse is sent in, the protons are tipped out of alignment, absorbing energy in the process. Then, just as precisely as it began, the pulse stops, marking the end of the energy input phase. When the pulse ends abruptly, a crucial transition begins. The protons, now energized, begin to relax and gradually realign themselves with the strong magnetic field, returning to their lower energy state. As they relax and realign, they release the absorbed energy in the form of faint radio signals, like tiny echoes of the initial pulse. This released energy, these faint radio signals, are the key to unlocking the secrets within and creating the detailed images we see in an MRI. The sophisticated MRI machine patiently listens for these subtle signals, capturing them with highly sensitive detectors. These signals, though faint, hold the secrets to your body's inner structure, revealing the subtle differences in tissue composition and density. It's a delicate and carefully controlled dance between the principles of physics and the complexities of biology, all orchestrated with incredible precision. Every scan is essentially a conversation with your atoms, a way of interrogating them, and listening to their responses to learn about your health. Now let's delve deeper and see how these seemingly simple signals are transformed into the detailed and informative images that doctors rely on. Here's where the magic happens. As protons relax, they emit radio signals, tiny echoes picked up by the MRI's receiver coils. Protons in different tissues relax at different speeds, creating unique signals. The MRI computer measures these differences, called T1 and T2 relaxation, to distinguish tissue types. Bright signals, dark signals, each tells a story about your body's chemistry. Gradient magnets tweak the magnetic field, letting the machine scan your body slice by slice. By stacking these slices, the MRI builds a 3D map of your insides. It's not just a photo, it's a detailed map of health and disease. MRI reveals what's healthy, what's not, and helps doctors make life-saving decisions, all from the dance of protons and the language of radio waves. That's the power of MRI imaging. If you've had an MRI, you know it's loud. Banging, buzzing, clanging. That noise? It's the sound of science. Gradient magnets rapidly switch on and off, vibrating inside the machine. These vibrations create the signature MRI soundtrack. Each scan sequence has its own unique rhythm and sound. The noise means the machine is working, mapping your body in real time. Earplugs are a must, but don't worry, it's all normal. The racket is the price of precision. Next time you hear it, remember, it's the sound of physics revealing the invisible. Science in surround sound. Why use MRI? What makes it so special that doctors and researchers rely on it so heavily? When we have X-rays and CT scans, which are often faster and more readily available, X-rays and CT use ionizing radiation. This is a key difference. X-rays are great for bones, providing clear images of skeletal structures. But X-rays and CT scans are not ideal for repeated scans due to the cumulative effect of radiation exposure. MRI uses no ionizing radiation, relying instead on magnetic fields and radio waves. This makes it safer for frequent imaging, especially for patients who require regular monitoring. Furthermore, MRI excels at showing soft tissues, where X-rays often fall short. Think of brains, muscles, and ligaments, areas where detailed imaging is crucial for diagnosis. MRI provides images with incredible clarity, allowing doctors to see subtle changes and abnormalities. Beyond structural imaging, it can even map brain activity using functional MRI, fMRI, and it can visualize nerve pathways using diffusion tensor imaging, DTI, revealing the intricate connections within the brain. MRI is a dynamic tool, capable of capturing changes over time. It's not just a static camera, it's a real-time window into the body's processes. It's a window into the living, working body, allowing us to observe tissues and organs in action. So next time you see an MRI image, remember, it's the dance of a trillion protons, responding to magnetic fields and radio waves. It's the echo of radio waves, carefully manipulated to create a detailed picture. And it's the power of human ingenuity, constantly pushing the boundaries of medical imaging. Science isn't just in textbooks, it's a living, breathing process. It's saving lives and revealing the unseen complexities of the human body. What should we explore next in the world of medical imaging and beyond? Let us know your thoughts and suggestions in the comments below. Like, subscribe, and share this video with anyone who might find it interesting. If you learned something new about the fascinating world of MRI technology, Until next time, from all of us here, keep exploring, keep questioning, and stay curious about the world around you.